Hello friends, welcome back. In this video, we are going to look at a very interesting enhancement of our Tux of Math game. Tux of Math is part of the Scratch advanced curriculum in YByte, so students do this project. What I'm going to talk about is an enhancement to the basic project, and this enhancement is basically a laser shot. So first, let's see what this is. This makes the game quite interesting, and then we can see how we can go about building this, right? So what I mean by laser shot is it's going to get illustrated from this enhanced game. So notice that here I have these clones falling, right? So I have a question coming, so 7 plus 6, I answer 13. Then I answer say 10, answer 7, answer 11, answer 9, and so on. So notice that for all the correct answers, I get this kind of a laser shot coming from here, going towards the question and sort of removing the questions in a animated manner, right? So this looks really cool and is also a great programming exercise, right? So I thought I'll just tell you how this is all done. But before I go there, let's just compare and contrast a little bit with the basic game that we had. So here, yes, everything happens. Questions keep coming, but when I do this, they just disappear quietly, right? They don't do any of those animations, or neither is there a laser shot, right? So we are going to take this code here, and modify this to get that laser shot effect, and we'll do this in a step-by-step manner, right? So first, let's just try to understand what is it that we will do to get this effect, right? So for that purpose, remember the basic scheme of the game, where basically we had these clones, and each clone has been given a unique ID, using variables only for this sprite, and each clone is maintaining those IDs, as well as those IDs are getting stored in these different lists, right? So all the left clone IDs are in this list called left clone, all the right clone IDs are in this list called right clone, all the operator clone IDs are in this list called operator clone, right? And correspondingly, there's an answer, and there's a perfect correspondence maintained between all these lists, and that's why the game works. So like I said, you can look at the more detailed version of this, but the basic idea has to be kept in mind, right? Now, when we have to do a laser shot, right? So what do we have to do, right? Really, there are two things. First, we have to identify which question has been answered, right? Now, this is nothing new. In fact, we had to do this also to delete these clones, right? Because, we could be answering, say, 4 plus 9 is 13 in this case, or we could be answering 5 plus 3 is 8, right? So we have to figure out which of these questions has been answered, and correspondingly, number one, delete it. But in this case, we are going to also figure out the target for our laser shot. So remember, the laser shot starts at the bottom of the screen, but then it must shoot up to that particular question, right? So we will know what is the target by knowing which question has been answered. But additionally, we must also, in order to direct our laser shot, we must also know where on the stage this particular question is, right? Like I said, we have to know where the shot goes. That means we have to know the X and Y location for this set of clones, right? Now, how we are going to do this is also again using lists. So we are going to create two additional lists here, the X positions and Y positions, right? The idea here is to again maintain the correspondence, which means that for this group of clones, this is the X position and this is the Y position. For this group of clones, for example, 4, 5, 6, X1 is the X position, Y1 is the Y positions, right? Now, these two lists will be will be instrumental in figuring out where the shot has to be directed. But one thing I want to highlight is that if we take a closer look at these X and Y positions, right? Notice that these three groups of clones, they can be seen as one group. These three can be seen as one group. These three can be seen as one group. For the X position, we can just take the center clone's X position as the X position. And since the clones fall vertically, which means they come top down, our X position, in fact, does not change, right? So there's only one time we need to update this and we are done. However, the Y position keeps changing. But again, remember that the Y position for all these three is exactly the same. So which means that we can look at any one of these clones, right? We can look at the left clone, center clone, or the right clone, and accordingly we can update the Y position, right? So that's the idea we're going to use to implement all this, but it's actually a lot of steps. So basically we are going to do this step by step. First thing first, I'm going to ensure that there are no repeated answers in my in the screen, right? Which means that every question that's on the screen basically has a unique answer. Now, why do I do this? Because this helps me to unambiguously figure out where my laser shot has to go, right? There's never two places that it has to go, right? So I'll do this. You can do it in like at least two ways I can think of, but I'll just use a simpler method. So what I am doing here is that I will put a check before this question is entered into the answers list, right? So remember, first we create the answers list and then we create all those clone IDs in our scheme. So before it's put in there, I can, check whether this question is already, this answer is already present, right? So the way I do that is that I'll set up a variable. Let's say I'll call it correct, answer. And what I do is to say, before I create the clones and all that, so I'll say set, for example, correct answer to temp1 plus temp2 minus 2. Why all this? Because remember, this is the correct answer. And now I can just check, right, if this list answers already contains correct answer, right? So I can go and say, if the list contains correct answer, then I don't do anything. However, if the list does not contain, right, which means I must use a not operator, and I say if not answers contains correct answer, right? So if I say not answers contains correct answer, let me just get that. Okay, so if not answers contain correct answer, in the variables, I go and pull in this variable. If the not the answer contains correct answer, then go and do all of this, which is basically to create the clone, enter to answers and so on and so forth. Another way this can be done is to use a repeat until, which means I can wrap these statements in a repeat until I get this answer not repeated, right? So that's another way of doing it, but this suffices for now, right? So basically what this will do is that our answers list only has unique answers, right? So we can actually see that working. For example, 9 plus 7 is 16, 6 plus 1 is 7, 3 plus 5 is 8. So all these answers are guaranteed to be unique because of this statement, right? Now, having done this, let's go to the next step, which is that when the clones are formed, I'm going to record their X and Y positions, right? So for this purpose, I'm going to create two lists right away. So I'll go call them, let's say, in the list section, I'll go and say, make a list, call it, say, X positions. And I'll make another list, call it, say, Y positions. SITIONS. Yeah. So now these two lists, remember, for any list project, I recommend, and we must do it. First, I go and delete everything from these, right? So that there's no history, the game starts afresh, right? So delete all of X positions and also go and delete all of, say, Y positions. Now this we must do. Now remember that the purpose of this list is to keep track of the X and Y positions of a group of clones. Right now, as we saw, the X position can really be just the X position of the operator, right? Which means that the moment these clones are started to form, which means we figure out, okay, these clones can be formed. The moment that happens, I can in fact go and make my first entry into the X and Y positions. And I can do that by adding two, let's say I'll just add two statements here right after creating, say, I can do it, say, just before creating the first clone, or we can do it right after that. That's also okay. So I will go and do that here. And now notice that I'm doing it right at the first clone, right? That's why my values will be as they are, right? So what I will do is that I will say to X position and to Y position. I'm going to add something to X and Y positions. The question is, what is it that I'm going to add, right? So basically, I'm going to add to both of these. For the X position, remember, this is the first clone that we are talking about, and the operator clone is what we are interested in, right? So the way we have done it, we always change by 25. So we go 50 minus 25. So I can just say in the X position, I can put an operator, say, add X position plus 25. Right now, this 25 is because of my game. If your spacing is different, it will be different for you, right? So I'm going to say add, say, for example, X position plus 25 to the X positions. For the Y position, I can just add the Y position, right? Because remember, for all the clones, Y position is equal, and we can just use the leftmost, right? Now, once again, this X plus 25 is because I want to make sure the center clone's X position gets added into the list, right? Now, if we just look at this right now, if I just run this thing, notice the clones are all showing Y position 180. That's because they all start from there. However, the X position is depending on where the center clone is. I mean, this got over now. We can do it again. So for example, minus 94, the center must have been there. 6 plus is minus 108, and so on and so forth, right? So this is the first part of it. We have created those lists. We have added the X and Y positions to the list X and Y positions, right? Now moving forward, I'm going to have to keep updating the Y position. Remember, X position is not going to change, but Y position will change. However, it's not that hard really, because like I said, as illustrated to you, the clones in a particular group, right? So if I look at, say, this group here, all the clones have the same Y position, right? So which means that I can assign one of the clones this job to keep updating the Y position. And in this case, I will choose the clone on the left side, right? Which means that all these clones, which means this left clone, or say this left clone or this left clone, will be assigned the task of updating these lists, the Y position list, right? But how does this actually work out in the code? Well, we can put a little bit of code inside when I start as a clone, right? So, okay, so when I start as a clone, I think for me it's up here. So what I'm going to do is that all these clones are falling, but I can ask clones which are on the left side, right, to update the list of y positions. And how do I know which clones are on the left side? Well, we already have that information, and it's basically a part of, so I'm just going to put, I'm going to put an if condition first. So over here, I just go and insert an if condition above this delete list thing. So I'm going to say, okay, if my clone ID is contained inside left clones. And why is that a valid thing? Because remember, all the clones IDs on the left are actually part of that list, and that list is actually active, which means the clones actually get deleted once they're answered. So it's all perfect, right? I can just say if in the list section, I can go, in the list, I can say if list left clone contains, there you go. So if list left clone contains clone ID, which means, I mean, this in simple words, what we are telling is these clone IDs are all unique. So only those clones which are in the list left clone, which means they are the left clones, are going to do this thing, right? And what do they do? Well, they have to update the y position, right? Now, how do I know which item to update, right? Remember, this y positions applies to an entire group, right? So for example, if I'm looking at the group number 2, right? So I must update the position of y number 2, right? So group number 3, I must look at y number 3. So I can also show probably the left clones here, in this list. So what I'm trying to say is that, for example, my left clones are, let's say the first group here, position is, this position needs to be updated. For the third group here, which is clone ID number 7, I must update third position, right? So where I'm getting at, if you're thinking carefully, you will realize is that I am interested not in the item here, but in fact in this number, the index, which is the item number, right? So I'm going to say in the y position, I'm going to use an operator called the replace, which will basically replace a particular item of the list. So I'm going to say replace, let's say, of something of y positions with the present y position. Now, what is that something we'll come to in a moment. So I'll say replace, let's say this present y position would be y position. Now, what is this item, right? Now, remember, like I said, this is basically the item number of that clone ID in the left clone list, right? So it's complicated, but it sounds complicated in code, but it's not that hard, because what we are really doing is that we're figuring out where in this list this clone existed, and that item we must update here, right? So I'm going to say use item number of clone ID in the list, right? So I'll go here, item number of, say, clone ID in, let's say, left clone. Now this has to be left clone, because otherwise this whole concept will fall apart, right? So condition happens only when it's in the left clone, right? Now once I do this, let's just see for ourselves these lists getting updated, and if you get this correct, chances are you've got the most hardest part of this thing in control, right? So the 0 and 1, notice the first guy is everybody's y position is changing because it's getting updated as they go along. Once they reach the bottom, of course, they stop falling, and that's why the y position stagnates. Right now, we can see this a little bit more slowly. For example, to do this, I'll just say maybe wait for 4 seconds and then just generate a number, and I'll also put this only in the corner. So let's say in fact, I'll just remove this so that it becomes easier. So maybe I'll say set yx to say something like 100, right? And then I can move these guys here, right? So when I do this, just for illustration, notice the first set of clone comes in. I expect to come somewhere here. Oh, so 100 is somewhere there. Okay, my bad. So, but notice the first clone came at 125, but its y position keeps changing, and likewise for the other clone. So you can do this experiment yourself. The y position is getting updated quite correctly, and what I will do is that I will, get this back to, let's say, wherever it was, so that I don't miss this. But to get the idea that x and y position is getting updated here, right? Now, this is the trickiest step. It took longest. Now, once we have done this, let's go back to our scheme here. We are going to figure out, once this question has been answered, I have to update a target location, right? So we know the y position, we know the x position. We have to go to the position where we figure out if this question has been answered, right? Now, how does that happen? Remember, a question is asked, and then we compare if the answer that we provide is part of this list called answers, right? So let's go back here. I'll come in here and I'll say, okay, look, when I basically receive some answer, right? When I receive some answer, all of this is already happening, right? So we are figuring out which question is being answered. We are basically figuring out if the question has been answered, and so on and so forth. So this is all in place. I'm going to create two variables here, right? I'll just call them, say, target x and target y, right? So target, say y. So target y. Yeah. Now, if I do this, now what I'm going to do is that I already know which question has been answered. So what should I set the target x and target y to once this has happened? Well, I will set them to, so I'll come here. I know which question has been answered. I'll just put two statements first. I'm going to set target x and target y. Target x has to be the x position of that group of clones. Target y also has to be the y position of that group of clones. Now it's actually very simple. If you think about it carefully, all we have to do is to duplicate this, but the list we are looking at, index is the question number. Remember, the list we are looking at is x positions in this case, and the list, I duplicate this and I go to the list, y positions in for the target y. Right now, we'll see this working first before we move on. But with one more thing I want to do, remember, I'm maintaining a perfect correspondence between these lists. Right? So we delete the clones, we also remove the answer, right? So I'm going to do the same thing for my x and y position so that the correspondence doesn't break, and I will immediately go and delete these two items also from the x and y positions, because in a way their job has been done, and we can go and remove this for the same logic that we removed all these other clones and the answer, right? So I'm going to say delete index of x position, delete index of say y positions. Now we can see this in action. I'll just put these two lists here, and I'll answer a question, and I'm going to make my, let's say, correct answer is, I can hide the correct answer, that's okay. I'm going to show the target x and target y, right? So let's say probably here target x and say target y. Then we can start the game, right? So let's see. Now the first question that comes in, so the answer, okay, so I can't see this here. Maybe I should just go back and fix this a little bit. I'm going to make the clone appear at x of 0, right? So I mean, previously it 100, but 100 comes too much to the right. So I'm going to say x of 0. So I think this should come reasonably well. And I'll also move this a little bit so that I can see them more carefully. I mean, this is always a challenge with lists, to arrange them nicely, right? So I'm going to put them maybe like this. So I can see x, y. And now when I see the clone coming out, so 4 plus 4 is the question. I'll answer 8. And notice my target x and target y is wherever this x and y was, right? So for example, x is 25, y must have been minus 22. If I answer, let's say if I can answer something faster. So target x and 9 plus 6 is 15. This time target y is 86, because the question must have been at 86 when this was answered, right? Now with this done, in fact, we are almost there, right? Now we just have to use this target x and target y to create a laser shot, and that brings me to the next step here, which is that I know the target location. I know where I have to go with this. I'm going to draw a line to that target location. For this purpose, I'll use another sprite. So I'll just call a sprite, and this sprite is really like a, I'm just going to paint a sprite. Just the costume is really dummy here. It doesn't need to be, but just for the sake of visualization, we create this and just call it, let's say, bullet, right? I just call it bullet, and the code for bullet is basically going to use a pen extension, because all I have to do is that this bullet has to be hidden, right? So when when I get, let's say, when flag click, I go and hide this bullet. I'll go and say hide this. Now when I get this command that I have to draw a line, right? How do I get this command? Well, once the question has been answered, right? Once all of this, bookkeeping has happened, right? Which means that question has been answered, everything has gone on. I can actually give a broadcast here called shoot, right? So once all this happened, I can give a broadcast here called shoot. Of course, the name doesn't matter, but shoot seems reasonable here. So, I'll give a broadcast here, say shoot. So when this bullet receives shoot, right? So I say when I receive shoot, I'm going to have to draw a line. But remember, to draw a line, I must use the pen extension, right? So I'm going to call in the pen extension, from here. So pen, we have seen this many times before. What I'm going to do is that I'm going to make this guy go somewhere to the bottom and then shoot a line towards the target x and target y, right? So I'll say go to, let's say 0 and minus 125, because I want it to go to the bottom. Put the pen down, so I go to the pen. So pen down means start drawing. I'll put the pen down and then glide very quickly to the target position. Now, why did I choose glide? Because it kind of creates smooth movement. So I'll just say, and I can control how fast this happens, right? So I can go and say glide very quickly to say target X and say target Y. Now, once I do this, the line would be drawn. very quickly I'll go and put pen up, because if I don't do this, I'll have a lot of extra lines created. So I'll go and do a pen up here, and thereafter I will immediately erase this line. So that creates like that fleeting effect, which looks nice, right? So let's see this in action. When I, for example, get this, now these questions are going to come from here. 4 plus 4, 8. I get this line, right? So 6, I get this line. So 4, I get this another line, right? So now it's almost ready. 12, and we've sort of understood the logic here, what's going on. I'm just going to do one little change here, which is that I'm going to make these sprites have a little bit of animation, right? So that looks nice because it looks like they've been hit by a laser and then they disappear. In fact, that part is actually quite simple. All I have to really do is that when I start as a clone, right? So remember, all these clones, basically they're going to get deleted at a certain point. So when I start as a clone, when I know that I have to be deleted, my name has appeared in the delete list, and I'm going to get deleted just before that, right? Just before I actually delete this clone, I can make them do a little bit of animation, right? And how do I do that? Well, I just use a very simple animation here. I say repeat 10 times. Let's say, okay, so before delete this clone, I have to be a little bit careful here. Before I delete this clone, so I know they're doomed, they're sort of going to go away. And what I do is that I just make them randomly, change their X and Y position, and that looks good enough for an animation. So I'll go and say, for example, here, let's say, so change, change X by some number and also change Y by some number, but I just use a random number here so that they just kind of move around a little bit, right? So I'll say change, pick random, say -4 to 4, and also pick random, duplicate this, pick -4 to 4, right? And also, just to stabilize this a little bit, I add a little bit of a weight here. So this looks nice, and then I think I should be getting a decent animation here, right? So let's just see this in action now. So what happens here? When I click the flag, 6 plus 4, 10. Notice my sprites do a little bit of a dance when they go away, and this looks really cool, right? So if I hide, if I sort of go back to my, my controls here, and I hide all these lists, I don't need them. I can hide this target X, target Y. I can in fact hide these lists as well. So X positions, Y positions, left clone, I remove them. And now I can also make my game back to its original glory, which means I do not fix this 6 to 0. In fact, let them come from wherever they want to come. And now we have a game which is quite just 2 plus 3 is 5. I get this nice laser shot. 1 plus 0 is 1. 9 plus 6 is 15. 5 plus 0 is 5. You can actually add a small sound effect as well. It looks cool, right? So I hope you enjoyed this. I think this is great programming. This is a beautiful game. Enjoy programming. Enjoy Scratch as always. Take care. Thank you so much. Bye-bye.